Since 1995, our exoplanet catalog has rapidly expanded. We have now confirmed over 4,000 worlds outside our solar system, with a further 7,000 or so suspects waiting to be classified, according to NASA. As our observation methods improve, this discovery process has only really just begun. And later last year, the James Webb Space Telescope was launched, with part of its mission dedicated to search for exoplanets. A surprising factor has started to present itself as we learn more about worlds outside the solar system. The universe is weird. Really weird. From worlds that rain iron and glass to diamond worlds, and planets that have escaped the grip of their parent stars, our burgeoning exoplanet catalog demonstrates that our own solar system is reassuringly boring. So again we are here with some interesting stuff about universe. Let's know some of the strangest and weirdest exoplanets ever detected. First, let's talk about WASP-76b. Spotted in 2013 and further investigated by the Espresso instrument on the Very Large Telescope in 2020, WASP-76b is a planet that is tidal locked to its parent star BD plus 01316. This means that one side of the planet permanently faces the star, causing scorchingly hot temperatures of around 2,500 degrees Celsius, hot enough to vaporize iron. The star-facing side of WASP-76b is roasted by radiation that is thousands of times more intense than that Earth receives from the Sun, while the side that faces away from the F-type star experiences perpetual night. Yet even though the day side of the planet experiences hellish temperatures, that doesn't mean that conditions on the night side are a walk in the park. The side of WASP-76b that faces away from the planet's parent star is cooler by at least 1,000 degrees Celsius. But this means that when iron vapor is carried across the hemisphere by powerful winds, they are cooled, forming liquid droplets. These droplets of molten iron then fall, bombarding the cooler side of the planet. Now we are gonna talk about HD 189733b. From space, HD 189733b may appear to be a beautiful and tranquil world, resembling a giant glassy blue marble. With exoplanets, though, appearances can be deceptive, and this is definitely the case for this gas giant planet that completes an orbit of its star in just 2.2 days. In fact, its beautiful blue hue arises from its deadly weather, particularly the molten glass rains that pelt the planet's surface. Yet, this isn't the extent of the planet's almost maniacal weather conditions. The exoplanet also experiences winds of around 9,000 kilometers per hour. These supersonic winds cause the exoplanet's glass rains to arc sideways towards the ground rather than just falling, also picking up silicate particles, turning them into microscopic projectiles. HD 189733b isn't just interesting to astronomers because of its unusual and hazardous weather though. The giant exoplanet has been observed to possess an atmosphere that is much larger than scientists would expect for such a world, according to NASA. This extended atmosphere works to catch more of the considerable radiation HD 189733b receives from its parent stars, thanks to its perilously close orbit, meaning the gas giant experiences temperatures as high as 930 degrees Celsius. The fact that the exoplanet's atmosphere is capturing so much intense radiation from the stars of the HD 189733 binary system means that it is rapidly being stripped away to space. So now we talked about HD 189733. Now we will know about Gliese 1132b. Gliese 1132b is similar to Earth in a striking number of ways. Its radius is only slightly larger, as is its mass. Even its age is similar to that of our planet. It is about 4.5 billion years old. But this world does have one striking difference. It orbits much closer to its red dwarf parent star, completing an orbit in just 1.6 Earth days. This proximity results in Gliese 1132b experiencing a much higher surface temperature than our planet at 137 degrees Celsius, with the intense radiation stripping the exoplanet's atmosphere. Astronomers have recently discovered that something extraordinary is happening on Gliese 1132b. The gravitational influence of its star, 20% larger than the Sun, creates intense tidal forces that squeeze and stretch the planet. This flexing gives rise to violent volcanic activity and causes gases to rush to the world's surface. These gases are building the world a second atmosphere, according to NASA. Whilst this is exciting in itself, being the first time astronomers have ever spotted anything like this, the regrown atmosphere due to its origin. It also provides astrogeologists with a unique opportunity to study the interior chemical composition of an exoplanet. Now let's talk about Upsilon Andromeda B. Upsilon Andromeda B is another exoplanet that is probably tidally locked to its host star, completing an orbit in just under 5 days. What makes this planet an extreme world is the radical difference in temperature between its dayside and nightside. Whilst the dayside experiences temperatures as high as 1600 degrees Celsius, the nightside is considerably cooler, reaching temperatures as low as -20 degrees Celsius. This means that passing the hemisphere of this world could be considered equivalent to jumping into a volcano. The reason this exoplanet experiences such a radical difference in temperature could be due to the tremendous size of its parent star Upsilon Andromeda A, or the fact that the star possesses a hotspot almost directly overhead this exoplanet. There are many strange and interesting worlds out there waiting for us. We will come up with some more of them in our future videos. Thank you for watching.